welcome to my YouTube video. This is Twitter Positivity. In today's video, we're basically going to look at Math 1100 quiz preparation. So we're just going to dive deep into the concepts of set theory. But before you do that, it's very important to understand what a set is. What is really a set? So we're saying a set is a well-defined collection of distinct objects called elements. So there are words that have been mentioned here. The first one is distinct objects. When we talk about distinct object, what we mean is in a set, elements are not supposed to be repeated. That's what we are basically trying to talk about here. So a set is going to be denoted by a capital letter. So when you see a capital letter, just know that something like that is a set. While elements are going to be denoted by a lowercase letter. In this case, it's a small letter. So small letters are for elements, while capital letters are basically for a set. So now, in set theory, without wasting much of your time, since you're preparing for a quiz, we're just going to look at the set operations. They are going to look at the set operations. The first set operation that we're going to look at is basically the union. What does the union stand for? So the union of two sets is the set of all elements that are in either sets or both. So for example, if I've got, so the union is given by the symbol U, by the way. So if I've got set A, then they say union set B. What they're basically telling me is to combine the elements that are in set A with the elements in set B. So for example, if I've got set A if set A is 1, 2, 3, 4, and set B is equals to 4, 5, 6. 4, 5, 6. How is A union B going to be? How is A union B going to be? So A union B means that I have to combine set A, combining it with set B. So how is it going to be? So we realize that it's going to be 1, 2, 3, 4. Since 4 appears twice, that's where now we're saying a set has to have distinct elements. I cannot repeat or put 2 4s here. No, I'm just going to get 1 4 since it's an element there. Then that is 5, 6, like that. So this is how A union B is supposed to be. I think let's move to the next set operation. In this case, it is intersection. So the intersection of two sets is the set of elements common for both sets. So the symbol for intersection, let me write it down here. Intersection, the symbol is N. So we know that if we were given to say, find the intersection of A, find A intersection B, and I'm given a set A to be equal to 1, 2, 3, while set B is given to be 3, 4, and 5. How is A intersection B going to be? Since we are saying we are just looking at what's common in both sets. So what is really common in both sets? Let me use another color. So if I use that, I'll realize to say the elements that are common in both sets is just 1, which is 3. So 3 is common in both sets, hence that is the answer to the question in the case where you have been asked to find A intersection B, or rather find what is common in both sets. Let's try to look at the other set operation. In this case, we're going to look at the relative complement. The relative complement. So the relative complement is also known as or referred to as the difference of sets. Mostly it is given by A minus B in the case where we pick A and B. What it means is that the elements, so we're talking about, what it means here is, if we were to interpret it, we can say this is the same as having A intersection B complement. In simpler terms, we are saying A is the set of elements, but A is a set of elements, also B is a set of elements, but the elements that we're talking about right now are elements that are in A but not in B. That's what it means. So the relative complement of B in A is a set of elements in A but not in B. That's what it means. So if I add set A to be equal to 1, 2, 3, and 4, then set B to be 3, 4, and 5. What do we expect? What we expect there is, realize to say, if they ask us to find A minus B, you must first interpolate it to say A minus B is equal to A, you change it to intersection, then anything that follows this minus symbol is going to carry a complement, like that. So you can just say, what is our A? You list A to say that is 1, 2, 3, and 4. Then you look at B complement. B complement, if we are looking at B complement and we have a universal set, by the way, if our universal set is, if U, the universal set, let me use the other symbol. Let's assume our universal set E is equal to elements from 1 all the way to 10, like that. If that is our universal set, and A and B are subsets of the universal set, meaning both A and B are coming from the universal set, then how is our B complement going to be? So we are looking at elements that are not found in B, but they are present in the universal set. I repeat, we are looking for elements that are not found in B, but they are present in the what? In the universal set. So let's compare. So B has got 3, it also has 4 and 5, implying that the complement of B is going to be 1, 2, that is 6, 7, 8, 9, and 10. That is our complement. But what are they looking for really? They're looking for what is common, the elements that are common in both sets. So A intersection B complement, since I'm comparing these two sets, I'm comparing set A and I'm also comparing set B complement. I'm trying to look for what is common between the two sets. I'll realize to say the answers are just 1, 2, 3. 3 is not part, sorry. That is 1, 2. I think it's just 1 and 2. These are the only elements that belong in A intersection B complement. Like that, it means that you are done. The order of the complement of a set. So looking at the complement, we're just basically looking at the elements that are not found in a particular set, but they exist in the universal set. So the complement of a set is a set of all elements not in that particular set, but they are present in the universal set. For instance, if you have got the universal set to be, if our universal set let me use E. If our universal set E is equals to 1, 2, 3, 4, 5, 6. If this is our universal set, then they say our A is equivalent to 2, 4, 5, like that. Then they're asking us a question to say, find a complement. So when I'm looking at a complement, I'm basically looking at elements that are not found in A. I'm not looking at elements in A, but I'm looking at elements that are not found in A, but they are present in the universal set. That is a very key point. It's a key point that you're not supposed to forget, because if you're looking for a complement, you should compare it to the universal set itself. So a complement in this case is going to be that is 1, 3, and 6. These are elements that are found in a complement, because these elements are not in A, but they are present in what? In the universal set. So basically, these are the operations that we're supposed to focus on. Moreover, there are also rules, laws of algebra, algebraic laws of sets, where we look at the idempotent rules. We're looking at maybe A intersection A. What the answer can be? The answer is basically A. Maybe we look at another rule to say A union A. If I combine the elements in A plus the elements in A, what am I going to get? I'm going to get A. Here it's more like I've got set A and set A. I've got two set A's and I want to compare what's common. Basically, you're just going to find out to say the common thing is just basically A. Then if I've got 3, A intersection E. In this case, E is the universal set. You will realize to say, since A is from the universal set, is a subset of the universal set, if I find the intersection, the answer is just going to be A. Then the fourth one, if I've got A intersection an empty set, what is common between set A and an empty set? Since an empty set doesn't have elements, but A has elements, if you want to look at what's common, you realize to say there will be no common thing. There will be no common elements, because the other element is empty. It has nothing. It has nothing in it. So implying that our answer is just going to be empty set. Then 5, another point that we can be interested in is A complement intersection A. So A complement intersection A, there is no commonality there. A and A complement have nothing in common. So the answer is empty set. I think we can try to illustrate what we mean by saying A complement intersection A, the answer is an empty set. So when I've got A here, like that, I've got the universal set. Let me even do this. You just draw one circle like that. Let me even use a different color. So like that. So that is E and that is A. So if I say A complement, meaning I'm talking about around A, shade around A. So this means shade around A. So let's shade around A. Let's use green. We're shading around A. We're shading around A. Then they're saying intersection refers to change the way you are shading. So the way our lines were arranged when we were shading A complement, let's change the way we are shading. So now we can use maybe lines going like that and shade A. So shade A complement, we have shaded. Then the next is intersection, which says change the way you are shading. That's what it means when you're shading. Then shade A. So in that case, since we have been commanded to change the way we are shading and shade A, let's change. So we'll change the way we are shading and shade A. So in this case, we'll shade like that. Oh, sorry. And shade A. So A is basically this. Do we have anywhere where the lines are meeting? The answer is no. Since we are focused on finding if we have got any space where lines are meeting like that. Like that. Now there is no space where lines are meeting like that. So implying that there is nothing in common between A complement and A. At the end of the day, that's an empty set. Alright, let's move to the next part. Oh yeah, so we have got questions that we need to look at. Questions like this one. So this question is saying simplify the following. We've got P complement union open brackets Q minus P close brackets, then everything has complement. So there are some things that you're supposed to pay attention to before solving this question. The first thing that you're supposed to pay attention is to each time I've got P complement close brackets, I've got complement outside. These two complements can cancel and you're going to get P. If I've got intersection complement, the answer is union. If you have got union complement, the answer is intersection. That's what you're supposed to pay attention to. Alright, so let's now try to solve and see the outcome of this question. So, solution. What I'll start by first dealing with what's in the brackets. So I'll say this is P complement union open brackets, that is Q. Then this relative complement here, I'll first interpolate it and say that means intersection. Then what follows it, in this case it's a P, it will also carry a complement. That's the interpretation. Then those brackets with that complement. Thereafter, I can distribute this complement now throughout. In this case, it's going to be complement times P, that is a P. Complement and union, in this case, we have already established that union complement, the answer is intersection. Open brackets. So I can just say this is Q intersection P, then I just bring the complement here, like that. We still have the complement there, and then I put it there. So this is going to be P intersection. So I distribute the complement throughout. This is going to be complement times Q, that is open brackets, that is Q complement. Complement and intersection, that is union, that is P. Then what are we going to get? So in the brackets, pay attention now. In the brackets, what I have here is Q complement union P. I'm combining two sets together. So I'm combining Q complement, I'm also combining P. Now the question is, what they want us to relate what we have in the brackets to what's outside here. So when I've got set P like that, then they want to find what's common with this other set, of which this set is combined. We have got Q complement union P. So realize that what's common here is basically P. Even if we try to shade this set like that, let's try to shade to illustrate it in the Venn diagram. Maybe it might make sense. We've got this set and that set. In this case, we have got P and we also have got Q. So in short, what we have here is they're saying Q complement. Q complement, they're saying shade around Q. That's what basically Q complement means. Shade around Q. So we are shading around Q. Shading around Q. That is basically around Q. That is shading around Q. Then what else? They're saying union mean plus P. So don't change the way we are shading, but shade P. Union means do not change the way you are shading. Continue the same way, but shade P. So since we already started shading P, I can just continue and fill it up like that. That's what it means. then what else are they saying? They're saying now intersection. Since we are done with the brackets, now they're saying intersection. Intersection means change the way you are shading, then shade P. Okay, so let's try to use different color. So this is P. I change the way I'm shading now. I change, but I'm shading P, all of P. I'm shading P, like that, like that, like that. After shading P, how do we extract the answer from there? Since these two sets are related by intersection, there is this set and there is that set related by intersection. We're just basically looking at where two lines are meeting because that is the common point. In this case, you realize that that is basically O of set P. That's the reason why we picked P as an answer. Thank you. We move to the next part. I think B and A are basically the same. Let's try to look at this one. So when you look at this set, you're basically looking at Y union X intersection Y. So if we were to break it down to say this is more like Y, let me even use a different color. It's more like you're using Y union X in brackets. Since remember, when you've got different set operations outside and inside, we can basically apply the distributive law, which says A intersection open B union C is the same as A intersection B union A intersection C. Or you can also say A union B open B intersection C is the same as A union B intersection open A union C. That's what the distributive law is all about. We're distributing A. This is more like multiplication. We're distributing A throughout the brackets. So that's the thing. Y union X. Then we pick the symbol in between the brackets. That's what is going to be outside like that. And that is again Y union Y. What are we getting? Y union X is basically Y union X intersection. Y union Y, the answer is basically Y. So in this case now, it has shifted. It's more like I've got set Y, I combine it with set X, then at the end of the day, I try to find out what is common between that particular set that I've made with Y. Of which the answer I'm just going to realize that it's just going to be Y. If you want to see how we can illustrate such kind of a set on a Venn diagram, let's try to draw it. Most of the time it's very good. It's very nice to draw Venn diagrams and illustrate these sets. So we have got this set and also that set. So I've got X and Y. So what are we having? So it's more like they're telling you to say, we'll start from here. So it's more like they're telling you to say shade X, shade Y. Or let's start with the brackets. So we say shade Y, I'm shading Y. So the English I'm using is basically like that. Shade Y, I've shaded Y. Then plus, union means plus. In short, it also says do not change the way you are shading, just maintain the way you are shading, meaning the lines, maintain the way the lines are flowing, then shade X. So I'll maintain the way the lines are flowing, just join them together and shade X. I've shaded X. But there's outside the bracket saying now change the way you are shading. Now I'm changing the way I'm shading, then shade Y. Okay, so I've changed the way I'm shading, then shade Y. If I do that, I'll realize that since they are governed by an intersection just tells you to say, for you to pick the answer, look at where the two lines are meeting. So realize that the two lines are meeting in Y. That's the reason why I picked Y as our final answer. For D, I'm not going to solve it. you can just submit it in the comment section, but what we can do is I can just help you interpret and show you guys. We can apply the distributive law here. We have got two set operations, this one and that one, plus we have got what's similar here and there. In this case it's m, so we're going to bring out m since m is similar in both sets. Then you realize to say, if you're dealing with a distributive law, the symbol that is normally in between the two sets is basically the symbol that was inside the brackets. So we had the brackets, meaning the symbol that was there is union. So it was union of what? N and n complement. Whilst m is basically intersection. That's the reason it was m intersection n union m intersection n complement. Like that. Like that, like that. Then it means that you're working. You can just finish this up. If it's finished, send the answer. If it's not finished, you can send the answer in the comment section. Then another, as well as this one, I can just interpret and say this is a minus, we can start with the brackets, this is a intersection b complement, meaning it's going to be, this is a intersection now, meaning since this has been changed to that, meaning whatever follows it, which is this same, must carry a complement. So meaning this is going to be open brackets a intersection b complement, close brackets, complement. It's not yet done. You can finish it up and submit in the comment section like that. We can move to the next part of our preparation, where we're looking at Surds. So in part 2, that's where we're going to look at Surds. Thank you very much for watching our YouTube video.